Hi students, in this video we're going to cover piecewise functions. So our objectives are to define what a piecewise function is, graph a piecewise function, and evaluate a piecewise function. All right, so the definition of a piecewise function is it's a function that has at least two other functions that are graphed under a set of constraints. If f of a is not equal to g of a, then x equals a is a discontinuity. And like what that means is the only places that we can have a discontinuity are going to be the places where where our the points that aren't in our domain, or these breaking points for the piecewise function. So in this case, we know x squared minus 3, its domain is all real numbers, and x plus 4, its domain is also all real numbers. So the only place this graph could break apart is going to be where x equals 0. And so you have to ask yourself, what is f of 0? And f of 0 is going to be 0 squared minus 3, which equals negative 3. And so then g of 0 is going to equal 0 plus 4, which obviously equals 4. And since those two values aren't equal to each other, you would say x equals 0 is a point of discontinuity. And what that's going to mean is that if you were going to graph this, so this is not exactly what the graph looks like. Actually, we can draw exactly what it looks like. So x squared minus 3. So you have to choose points where x is less than 0. So if x is negative 1, we're going to have 1 minus 3, which is going to be negative 2. So if x is negative 1, we're going to have negative 2. And then we know that when x is 0, we're going to get negative 3. And so that graph is going to look like that, except we're going to have an open circle when x is 0. And then the line x plus 4, when x is greater than or equal to 0, we're going to have 1, 2, 3, 4. And we're going to put a filled in circle. And so that line is going to look like that. What happens is there's an open circle here. So there's a skip between this point and this in that point. And so that's why it's a discontinuity. It's like a jump in the graph. But we'll see that when we graph more stuff. All right, so when you're graphing a piecewise function, you need to plot enough points for each piece of the graph so that you understand how the shape of the graph looks. And then we have to remember basic things about end behavior, and we discussed that in the video over parent functions. So we're going to actually graph that example that we just had. So we're going to have x squared minus 3 if x is less than 0, and x plus 4 if x is greater than or equal to 0. So the x squared minus 3, we know that that is a parabola. And so all parabolas are going to look like this, more or less. And then x plus 4 is a line. And so the line is going to look like this, or is going to look like that. It's going to either go down to the right or up to the right. So for the x squared minus 3, all of our x values have to be things that are less than 0. So we're going to make our table. So we're going to have x, and for this one, we're using x squared minus 3. That's our f of x value. So x can be 0, but we're going to put an open circle. So when x is 0, we're going to get negative 3. When x is negative 1, we're going to get negative 1 squared. And just so we're clear, it's going to be negative 1 squared minus 3, and that's going to equal negative 2. And so then negative 2, we're going to have negative 2 squared minus 3, and that's going to be 4 minus 3, which is 1, and then we'll have negative 3. So you get negative 3 squared minus 3, and that's going to equal 6. So 4 points should be enough to graph a parabola. So we have the point 0, negative 3. That's going to be an open circle, and it's an open circle because the less than does not have an equal bar. So that's going to mean open circle. So then we plot the rest of our points. So we have -1, -2, we have -2, +1, and we have the point -3, +6. So that's going to be right here. And so we get the basic shape of a parabola. And remember, the end behavior for a parabola is going to mean that graph just goes up like that. So this is the left part of that graph. And so now we want to graph the other portion, and we'll graph that in, we'll say blue. So now we have x plus 4. And for the x plus 4 part, our x's need to be greater than or equal to 0. So you should always use the break point for your graph. So that means that we need 0, and 0 plus 4 is going to be 4. And for a line, you only need 2 points. So let's choose x equals 1. And so 1 plus 4 is going to be 5. So we have the point 0, 4. And the equal bar is going to mean a filled in circle. So we get the filled in circle at 0, 4. And then we're going to graph the point 1, 5. So again, you only need 2 points to make a line. So now we have Siri out of here. So our graph looks like this. And again, this is a discontinuity. Like, we don't have any y values that are between -3 and 4. So this is a discontinuity because there's a skip in the graph. Because we skip all of the y values between -3 and +4. So this is a discontinuity. X equals 0 is we're going to call this a jump discontinuity. And the reason we call it a jump discontinuity is that when you get down to -3 on the red graph, you have to jump up to y equals 4 for the blue graph. But again, how we graph a piecewise function, you just graph each section according to what the inequality tells you. So next we have the graph f of x equals, and now we have 3 different constraints. So we're going to say that this is going to be, well, since we already have blue, we're going to have blue for this. And you remember, for the square root function, it's basically going to look like this, or it's going to look like that if it goes left. And our x's are less than or equal to -4. So all of our x values have to be less than -4. So we're going to have x, and we're going to have the square root of -x. So the values of x that it makes sense to choose are going to be, first, you should always use that -4. So if x is -4, you have the square root of -4, which is the square root of 4, which is going to be 2. So when x is -4, we get a value of 2. So when x is -4, we get a 2, but we're going to put an open circle because there's no equal bar. And the next value you should choose should be a number that's a perfect square. So we're going to use -9. And so we get the square root of -9, and that's going to equal 3. So when x is -9, we get 3. And this graph is just going to keep going. So its end behavior, remember, for a square root function, is going to go to infinity. So we get that. And so then for our middle function, 2x plus 5, x is between -4 and +1. So we're going to have x, and we have the equation 2x plus 5. And since it's a line, remember, all lines are either going to do this or they're going to do that. And you only need 2 points to make a line. So we're just going to use the -4 as an x value and the 1 as an x value. So we're going to have -4, and when x is -4, 2 times -4 is -8, plus 5 is -3. And then when x is 1, 2 times 2 is 2, plus 5 is going to be 7. So we have the point -4, -3, And that's going to be down here with a filled in circle. And then we have the 0.17. That's going to be up here with an open circle. And it's an open circle because that is less than 1 and not less than or equal to. And we're just going to connect those with a straight enough line. So that's how we get our middle section. And then we'll use green. And so for the bottom thing, we have another parabola where that is x, and we have x plus 1 squared plus 3. So remember, that's really a parabola shifted left 1 and up 3. But we start, I'm sorry, I didn't even put a constraint here. This should be x is greater than or equal to 1. So all of our x values need to be greater than or equal to 1. And so the first value that you want to always use is that constraint value, which is going to be 1. And so then if we substitute in 1, we get 1 plus 1 squared plus 3. And so 2 squared is 4 plus 3 is 7. So when x is 1, we get 7. So we can actually fill that in. And then when x is 2, we're going to have 2 plus 1 squared plus 3, and that's going to equal 12. So when x is 2, we're going to get 12. That's actually off the graph. My apologies, but then we're going to get a parabola like that. So this is how we graph a piecewise function that has 3 constraints. We just graph each part, and in this case, we color coded it so that it was easy to see. So when you evaluate a piecewise function, you just look to see where the x value falls. So for number 1, we have to evaluate f of 2. So is 2 less than or equal to 2, or is 2 greater than 2? So in this case, because 2 is, so we get 2, that's less than or equal to 2. So say we label this as equation 1 and equation 2. That's going to mean this is a semicolon, by the way. So we need to use equation number 1. So that's going to give us 2 cubed plus 1. Actually, let's make that look better. So that's going to mean that f of 2 is equal to 2 cubed plus 1, which is 2 times 2 times 2, which is 8, plus 1 is 9. And then f of 4, so 4 is greater than 2, and that means use equation 2. So we want to use equation number 2. And so that's going to mean that f of 4 is equal to 4 squared minus the square root of 4, which is 16 minus 2, which equals 14. So that's how we evaluate a piecewise function. You find where the x fits in, and you just substitute the value in and evaluate the function. So even if we have 3 constraints, it's going to be the same thing. If we have g of -6, so -6 is less than -5. So we want g, let's label this. We have equation 1, equation 2, and equation 3. So this one is going to be equation number 1. So g of -6 is going to equal the absolute value of 3 times -6 minus 1. And in absolute value, that's going to be -17 minus 1, which is -18. But the absolute value of -18 is +18. So then for -5, -5 is going to fit the second equation. And that's because we have this equal bar on the -5. X can be greater than or equal to -5. So we want to use equation number 2. So g of -5 is going to equal 2 times -5 plus 3, which is going to be -7. And g of 0 is also between -5 and 2. So we want to use equation number 2 again. So g of 0 is going to equal 2 times 0 plus 3, which equals 3. And then g of 5, since 5 is greater than 2, you want to use the bottom equation, equation number 3. And so we're going to have g of 5 is equal to 5 plus 2 squared, which is going to equal 7 squared, which equals 49. All right, so that concludes our video on piecewise functions. A quick recap is for graphing a piecewise function, we just graph each part individually based upon the inequality. And when we evaluate a piecewise function, you determine where the x value, which inequality the x value fits, and you use that equation. All right, thanks for watching.